Hello and welcome everyone. This is Mohammed Inzamam from SAIMEDHA ECET Coaching Center, Koti, Hyderabad. In this video lecture, we are going to be discussing about all the PYQ analysis from the chapter Heat and Thermodynamics, and based on that analysis, we'll be seeing the PYQs and most important questions. Okay. So welcome to Physics Sadhana, everyone. You see, first of all, the analysis of the heat and thermodynamics. Okay. Previous almost 100 questions అనేది తీసుకుంటే heat and thermodynamics topic lo, physics, heat and thermodynamics topic lo, you can see that the maximum questions are getting appeared from the chapter, from the topic thermodynamic processes. After that, the questions are covering from what perfect gas laws, specific heat, fundamentals, laws of thermodynamics, first law and second law. But the maximum number of the repeated questions are coming from which topic? Thermodynamic processes. Okay. So in each type 1, type 2, type 3, type 4, fundamentals, basics, everything we are going to be studying in this physics sadhana. So analysis, you leave it to us. Technique, you leave it to us. Study schedule, you leave it to us. You just follow daily physics sadhana videos, evening 7 PM sharp. Okay. My dear students, 7 PM ప్రతి రోజు ఈ వీడియోస్ అనేది అప్డేట్ చేయడం జరుగుతుంది మాక్సిమం వీలైనంత వరకు. ఓకే, ఎన్ని సబ్జెక్ట్స్ పాసిబుల్ అయితే, ఎన్ని టాపిక్స్ పాసిబుల్ అయితే అన్ని టాపిక్స్ ఫ్రీ ఆఫ్ కాస్ట్ వీఆర్ గోయింగ్ టు బి అప్డేటింగ్ ఇన్ ద SAIMEDHA యూట్యూబ్ ఛానల్. సో మై డియర్ స్టూడెంట్స్, try and understand this analysis and based on the analysis all the PYQs and then most important questions. Thank you very much. Let's get started with the video now. Hello and welcome everyone. In this video we are going to be discussing about thermodynamic processes is one of the important topic in the heat and thermodynamics chapter of physics. ECET 2025 question number 1. This is a PYQ 2012 appeared question. We will be analyzing all the PYQs and based on which I will be giving you at the end of the chapter, at the end of the video, some important questions too. Question number 1. During an adiabatic process, the pressure of a gas is found to be proportional to the cube of its absolute temperature. Pressure is found to be proportional to cube of the absolute temperature. Here is mentioning about which process? Adiabatic process. Okay. In the adiabatic process, what is the relation between the pressure and temperature? We will be writing pressure is directly proportional to temperature. P1 by P2 is equals to T1 divided by T2. Pressure power will be 1 by gamma. Temperature power would be 1 by gamma minus 1. Let's send this 1 by gamma to the right hand side. So we will be writing like this. Pressure is directly proportional to temperature. This will go to the right hand side. This will become gamma. Already we are having here denominator gamma minus 1. Now in the question is mentioning pressure is directly proportional to temperature cube. That is indirectly saying that pressure is directly proportional to temperature power 3. So now we can compare and say that this 3 is gamma by gamma minus 1. And asked the question is what? Cp by Cv. That means gamma. Gamma is equals to what is our question? Given is gamma by gamma minus 1 is equals to 3. Okay. Cube of its temperature. The ratio of Cp by Cv for the gas is dash. Okay. So now gamma value will be depending upon the type of a gas. The gas could be monatomic gas, okay, polyatomic gas or diatomic gas. Monatomic, polyatomic or diatomic. Now we can say that this value, what value we can substitute here for making the gamma by gamma minus 1 is equals to 3. Okay. So we can write like this, gamma is equals to 3 times of gamma minus 1. Gamma is equals to 3 gamma minus 3. 3 gamma is minus gamma is equals to 3. 3 gamma minus gamma, 2 gamma is equals to 3. Gamma is equals to 3 by 2. That's how we'll be going to find out the value for the gamma, and gamma is equals to 3 by 2, which is usually the mixture of monatomic and diatomic gas. Okay. 3 by 2 is 1.5. Go through it. In this question, we need to learn about thermodynamic process, adiabatic process. What is the relation between the pressure and temperature? Let me give you all the three relations: pressure, volume and temperature. Volume would be V1 by V2. Pressure would be P2 by P1. Temperature would be T2 by T1. Volume power 1 only. Pressure power 1 by gamma. Temperature power 1 by gamma minus 1. Pressure and temperature are directly proportional but inversely proportional to volume. That's why here 1, 2 is there, so it will be 2, 1, 2, 1. Pressure and temperature are directly proportional to each other, so 1, 2, 1, 2, both are directly proportional to each other. Okay. Go through it. Moving on to the question number 2. Question number 2 given over the board is 2017 appeared question. 100 grams of water is heated from 30 to 50 degrees Celsius. Ignoring the slight expansion of water, the change in the internal energy. Change in internal energy, it comes from Joule's law. Okay. What is the change in internal energy? By default, for all the processes, we will be having only one formula. Constant volume process, constant pressure process, isothermal, adiabatic, polytropic. General law of expansion, change in internal energy formula never changes. Change in internal energy is equals to m into Cv into dt. This is the formula for change in internal energy. Change in internal energy where mass is given as 100 grams, so this is 0.1 kg, 0.1 kg. Cv value, specific heat of water, that is 4200 joules per kg Kelvin, joules per kg Kelvin, so kg gets cancelled. Finally, temperature changes 30 to 50 degrees Celsius, that is change in temperature 50 minus 30, that is 20, that is in a Kelvin. Okay, because change in temperature in degree Celsius and degree Kelvin both are same. Delta C is equals to what? Delta K. If I add here 273, it's not going to change anything because 273 gets cancelled. So Kelvin gets cancelled. Units would be in terms of joules. So what is it going to become now? 0.1, that is we can write here 1 by 10. 4200 as it is. This is 50 minus 30, 20. So the 0 gets cancelled. What is this value going to become now? 0, 0, 2 2s are 4, 2 4s are 8. 8400 joules in terms of kilojoules, 8.4 kilojoules. So this is going to become your answer. Fourth one. Go through it. From this question you need to learn that for all the process, isochoric, isobaric, isothermal, adiabatic and polytropic, all 5 processes there is only one formula for change in internal energy. What is that common formula? mCv dt. Okay, that was given by which law? Joule's law. It was given by a law called as Joule's law. That is internal energy is a function of water temperature only, proportional to temperature only. This was given by Joule's law. Moving on to the question number 3. Third question is, an ideal gas in a cylinder is compressed adiabatically. You see how many times this adiabatic question is getting repeated. Like one of the favorite process, thermodynamic process is adiabatic process. An ideal gas in a cylinder is compressed adiabatically to 1/3 of its original volume. If V1 is equals to V, V2 is equals to 1/3 of the original volume, that is V by 3. During the process, 50 joules of work is done. Work done is equals to 50 joules. On the gas, and that too, it is a compressive work. Compressive work is a negative work. Okay. The change in the internal energy is equals to what? Du is equals to what? We know the first law of thermodynamics, d dash q is equals to du plus d dash w. Where in the adiabatic process, heat transfer is equals to 0. In the adiabatic process, heat transfer is equals to 0. If heat transfer is equals to 0, then du is equals to minus d dash w. Minus of work done. What is work done? Negative 50. Negative 50. Minus of minus 50 plus 50 joules would be your answer. Okay. So what is the answer? Option number 1, 50 joules. Internal energy and work done both are equal. When the work is negative, compressive work is always negative. Focus on this now. Compression. Compression is what? Negative. Or you can say work done on the gas. On the gas is what? Negative work. Work done by the gas is positive work. Okay, work done. There are 2 types. On the system. Okay, by the system. When he says on the system, it is negative. When he says by the system, it is positive. When he says expansion, it is positive. When he says compression, it is negative. Okay, go through it once. Moving on to the next question. The next question given over the board is, in thermodynamics, heat transfer equals to 0, work transfer equals to du or minus du is true for. Just now we have seen this question that internal energy and work transfer both are equal but opposite in sign. It is valid for which process? Adiabatic process. So that was he is asking here. Heat transfer E dash Q is equals to du plus E dash W. Okay, this is going to be valid for which process? Heat transfer is equals to 0 and du is equals to minus D dash W. Minus. Valid for which process? Adiabatic process. Moving on to the question number 5. Next question. The next question given over the board is in a given process work is equals to 0 and heat is decreasing. Then for the gas what happens? We know that in constant volume process work done is equals to 0, because what is the formula for work done? Work done is force into displacement. Displacement equals to 0, piston does not move. When piston does not move, then displacement is equals to 0, so work is also equals to 0. There is one more formula, work is equals to PdV. As volume is constant, then what happens? The differentiation of constant is going to become 0, then work is equals to 0. In short, work is constant, work is equals to 0 for constant volume process. What is the first law of thermodynamics? D dash Q is equals to du plus D dash W. Here work done is equals to 0. If work done is equals to 0 and heat is rejecting out, then only the heat will be negative. Less than 0, that means it is negative. Negative means what? Heat is getting lost. When the heat from the piston cylinder arrangement is taken out, heat is moving out, that is the loss of heat energy. When heat energy is coming out, inside the gas molecule are going to be losing their energy. When you supply the heat, then temperature increases. When you reject the heat, then temperature decreases. So what is the answer for this one? Temperature will decrease. Okay. Volume will not increase because volume is constant. That's why this is wrong. Pressure will remain constant. No, pressure is going to be what? Reducing, because energy decreases, pressure also decreases. So pressure is going to be moving down. Okay. Temperature will increase. No, temperature decreases. So that's why these three are wrong. Okay. You supply the heat energy, temperature increases. Reject the heat energy, temperature decreases. Moving on to the next question. Which of the following statement is correct for isothermal process? Isothermal. Iso means what? Same. Here therm refers to temperature. That means same temperature. Temperature is going to be what? Constant. Temperature changes. No, is the wrong one. Exchange of heat takes place between the gas and the surrounding. Exchange of heat takes place. Yes, if temperature is going to be what? Constant, then heat and work is going to be exchanging. He is saying internal energy is going to be changing. We know the internal energy formula, du is equals to m into Cv into dt. Now dt is equals to 0, so du is also equals to 0. So internal energy does not change. Internal energy is a constant. Differentiation of constant is 0. Okay. It is a quick process. Adiabatic process is a quick process. It is a slow process. Adiabatic is a quick process. Isothermal is slow. When it is slow, then only the temperature will be constant. Isothermal is slow. So that's why this is also wrong. So which one is the correct answer now? Option 2 is the correct answer. That is, heat will take place in between the gas and the surrounding. Moving on to the next question. During an adiabatic, again you can see adiabatic question appears. Expansion of 2 moles of a gas, number of moles is equals to 2. The change in the internal energy was found to be equal to du is equals to 100 joules. Work done during the process will be. Okay, this is a which process? Expansion process. Okay, expansion. I told you expansion work is positive. Okay, I have given you the signs here. You see, work done on the system negative, that is compression work is negative, expansion work is positive. Based on what? He framed a question now. Expansion work. Okay. See here. Work done during the process will be dash. During adiabatic expansion, internal energy was found to be equal to 100 joules. Okay. The work done during the process will be what? Internal energy is decreasing, work is going to be what? Increases. So we can say that E dash Q is equals to du plus E dash W. Heat transfer is equals to what? 0. Heat transfer is equals to 0. And change in the internal energy was found to be equal to 100 joules. Change in the internal energy was found to be 100 joules is equals to what? Plus work done. So if you say work done is equals to minus 100 joules, work done during the process will be equal to the change in the internal energy was found to be 100 joules. If you can say that expansion process it is. So internal energy what happens? Decreases. Okay. These are the molecules. Molecules are releasing the energy. When molecules are rejecting the energy, then internal energy is going to become what? Negative. Molecules are releasing the energy. That's why expansion is going to be what? Happening. So if expansion is going to be happening due to the negative internal energy what decreasing, then work is going to become what? Positive. And that too, this is a which work? Expansion work. Expansion. That's why it is positive. So what is the correct answer? Minus 100 or plus 100? Plus 100 is going to become your correct answer. Okay. Go through it once. Moving on to the next question. Question number, it might be some 8th question I guess. Okay. 8th question. Let's see. In which of the following process the internal energy of the system remains constant? Internal energy remaining constant. Just now we have seen this question also. Isothermal process. You see, internal energy is what? Constant. Temperature constant, differentiation of temperature is 0. Entire value becoming 0, that means differentiation of U becomes 0. du becomes 0 means U is constant. That means internal energy constant is there in which process? Isothermal process. So isothermal, what happens? Temperature is constant. Then what happens to the differentiation of temperature equals to 0. What is the formula for du? du is equals to m into Cv into dt. What is dt? 0. That means du is also equals to 0. Differentiation of something is equal to 0, that something is what now? Constant. That means internal energy is constant when temperature is constant. Temperature increases, internal energy increases, temperature decreases, internal energy decreases, temperature constant, internal energy is also constant. It is happening in which process? Isothermal process. And the law is called as Joule's law. Okay. Moving on to the question number 9. The specific heat of the gas in isothermal process is isothermal process again. What is the formula for heat? Heat is equals to mc delta T. mc delta T. Then what is the C? Specific heat. Specific heat is equals to heat transfer divided by m into dt. We know that just now I have written the formula. dt value is equals to what? 0. dt value is equals to 0. If dt is becoming 0, anything by 0 will become what? Infinity. That is, specific heat value is going to become what? Infinity. For which process? Isothermal process. Okay. So what is the correct answer now? Infinity is the correct answer. Go through it. Up here 2019 question. Let's move on to the next question. The next question given over the board is 1 mole of oxygen is heated at constant pressure. Now comes the constant pressure, that is isobaric. Heat is what he is asking, the heat energy. The formula for heat energy is m into Cp into dt, where number of moles is equals to mass by molecular weight. So mass can be written as number of moles into molecular weight. Cp can be written as gamma r divided by gamma minus 1 times of dt. Okay. Starting with the dt first. What is the dt? It's saying that constant pressure 0 degree Celsius is the temperature, and which T1 is equals to 273 Kelvin. Okay. Heat must be supplied so that double its volume. That means V1 is equals to V, V2 is equals to 2V. We know that PV by T is the ideal gas equation, their pressure is constant. So we can write like this, V1 by T1 is equals to V2 divided by T2. If V1 is V, T1 is 273, V2 is 2V, T2 is equals to, okay, VV gets cancelled, and T2 is equals to 2 times of 273. That means we can write T2 is equals to 2 times of T1. Then what is the temperature change? dt is equals to, dt is T2 minus T1. T2 is 2 times of T1 minus T1, that is T1. T1 is equals to 273. So change in temperature is 273 only. Okay. Change in temperature is equals to, what's the value here? 273. When change in temperature is equals to 273, then what will be the value for this gamma R by gamma minus 1? We know for gamma, oxygen is diatomic gas, and for the diatomic gas the gamma value is equals to 7 by 5. Then gamma by gamma minus 1 is 7 by 5 divided by 7 by 5 minus 1. That is 7 by 5 divided by 7 minus 5 divided by 5. 7 minus 5 is 2. 5 gets cancelled, is 7 by 5. 7 by 5 is how much? 7 by 2 is how much? 7 by 2 is 3.5. So this value is going to become what now? 3.5 R, and this value is 273. What is the number of moles into molecular weight? Number of moles is equals to 1 and molecular weight is equals to, we can say this molecular weight m into R. M into R. This m into R is the formula for universal gas constant. Okay, mR. I should mention in the question that this value is R is not characteristic gas constant, it is universal gas constant. Okay, so what we can write here, m into R is Ru. So 3.5 Ru 273 is going to become your correct answer, assuming that this is the universal gas constant. So this is the correct answer. Go for it. Okay. So, moving on to the next question. The next question given about the bodies. The conduction of heat from hot body to cold body is an example of hot body to cold body. That means heat is flowing from one body to another body. In between some losses will be there definitely. So this is which process? Irreversible process. The real one. Real processes are irreversible in nature because total amount of energy cannot be conserved. Irreversible processes. Next question. Monatomic gas initially at 17 degrees Celsius. Initially at 17 plus 273. 3, 7, 10, 7, 1, 8, 9 is going to become what? 290, right? 290 Kelvin. 273, 283, 293, 290. 290 Kelvin it is. Monoatomic gas. Suddenly compressed to 1 by 8th of original volume. V1 is equals to V, V2 is equals to V by 8. The temperature after compression is what? T2 is equals to what? Mention in the question monatomic gas. For the monatomic gas, gamma is equals to 5 by 3. And what is the relation between the temperature and volume? T2 divided by T1 is equals to V1 divided by V2. Both are inversely proportional. Volume power doesn't have anything. Temperature is 1 by gamma minus 1. 1 by gamma minus 1 going to the right hand side, gamma minus 1. Okay. So T2 is equals to V1 by V2. That is V divided by V by 8. So VV gets cancelled. Gamma minus 1. That is 5 by 3 minus 1. 5 minus 3 by 3. 5 minus 3, 2. 2 by 3. So this is equals to 2 by 3. Into T1. T1 value is how much? 290 is equals to. This is 1 by 8. 1 by 8 will be going to the numerator. It will become 8. 8 can be written as what? 2 cube. 2 cube to the power of 2 by 3 into 290. 3 gets cancelled. 2 to the 4. 4 times of 290. 29 4s are 9 4s are 36. 4 2s are 8. 9 10 11. 116. Total value 1160. Okay. Go through it. This is going to become your correct answer. You see, again this is the adiabatic relation. Thermodynamic process, adiabatic is how many times you are repeating, you can understand now. Moving on to the next question. In an adiabatic expansion, a gas does adiabatic process. Heat transfer is equals to 0. A gas does a work of 25 joules. Adiabatic compression is gas does 25 joules of work while adiabatic compression is 100 joules. This is expansion, let's say this is compression. Compression 100 joule is negative. Work done on a gas. The change in internal energy in the two processes respectively are. We know that du is equals to minus d dash w. That is minus 25. Du is equals to minus d dash w. That is minus of minus 100. Answer is plus 100. So minus 25 plus 100 should be your correct answer. This is the correct answer. Go through it. Next one. Moving on to the next question. Question number 14. The volume of 1 mole of ideal gas changes from V to 2V. Temperature 300 Kelvin. If R is universal gas constant, then work done in this process is dash. Volume is changing. Volume is V1 is equals to V. V2 is equals to 2V. Temperature, the volume of 1 mole of a gas, number of moles is equals to what? 1. Ideal gas changes from V to 2V at a temperature of 300 Kelvin. At a temperature of 300 Kelvin. But this temperature is what? Constant. Temperature is a constant. Constant temperature work done formula is what? PV log V2 divided by V1. Okay. Or you can say NRU_T1 log V2 divided by V1. 1 mole is 1. Universal gas constant is R. Temperature is 300. Log of V2 by V1. V2 is 2V divided by V. V gets cancelled. So what is the answer now? The answer is 1 mole. So this is R into 300 log 2. So 300 R log 2 should be your correct answer. 300 R log 2 should be your correct answer, which is given in the option number 1. It is isothermal process. Moving on to the question number 15. The pressure density of diatomic gas is gamma 7 by 5. Changes to P2D2 during our operation adiabatic. Diameter density ratios are given, pressure ratio is asked. We know the formula. Pressure ratio in terms of volume is V1 divided by V2 whole to the power of gamma. Volume is inverse of what we can say density. So here we will be writing D2 divided by D1 whole to the power of gamma. Where D2 by D1 is given as 32. 32 is what? 2 to the power of 5. 2 to the power of 5. Where gamma is 7 by 5. So 5 gets cancelled. So your answer is 2 to the power of 7. That would be 128. 128. So this is going to become your correct answer. So that's all about all the PYQs from the thermodynamic processes. Okay, this is a part 1. I'll make a part 2 also, because maximum questions are coming from this thermodynamic processes topic only. Okay. Moving on to the important questions based on the analysis of the PYQs. Important question number 1. Ideal gas is heated from 20 to 40 degrees Celsius under a constant pressure. Then change in internal energy. This is an expected question now in the examination, so far not yet appeared. Okay. He is saying that temperature is increasing. T1 is equals to 20, T2 is equals to 40. Pressure is remaining constant. The change in internal energy is dash. What is the formula for change in internal energy? Change in internal energy is m into Cv into dt. When temperature change is increasing, is a positive value, then du also going to be what? A positive value. Doubles the original value, proportional to change in volume, proportional to change in temperature. You know, du is directly proportional to change in temperature. Proportional to temperature. So this is going to become your correct answer. We cannot say it is a double the original value. Okay. Because u1, u2 we cannot judge easily, because if you can say this is dt is equals to temperature value is getting increased, so internal energy also increases. But if u1 is known, then we can say u2 is how much value. Okay. So proportional to change in temperature is the absolutely correct answer. Certain amount of heat supplied to an ideal gas under isothermal condition, which results in isothermal process. Isothermal temperature is what? Constant. So temperature, rise of temperature is wrong answer. Doing external work and change in temperature. Change in temperature is saying again, change in temperature is wrong answer, because temperature is constant. Doing some external work, yes, work is going to be done. Increase in internal energy. We know that internal energy is proportional to temperature. If temperature is constant, then internal energy is also constant. So increase in internal energy is the wrong statement. So which one is the correct answer now? Option 3 is going to become the correct answer. Doing the external work. Okay. Moving on to the next expected question, important question. Monoatomic gas is suddenly compressed 1/8 of its volume. Then pressure of the gas is going to be changes by, okay, pressure P2 divided by P1. Volume is inversely proportional V1 divided by V2 whole to the power of gamma. Volume is is saying 1 by 8th V divided by V by 8. That means this V gets cancelled, whole to the power of gamma, that is 8 to the power of gamma. 8 is how much? 2 cube. Gamma for monoatomic gas 5 by 3. Gamma for monoatomic gas 5 by 3. 3 gets cancelled, 2 to the power of 5. What is 2 to the power of 5? 32. Similar question of 128 we did, 2 power 7. Now expected question is 2 to the power of 5. 32 is the correct answer. Next important question. An ideal gas at a pressure of 1 atmosphere, temperature is 27, compressed adiabatically. Then pressure becomes 8 times, final temperature is what? Okay, temperature is asking in terms of pressure. T2 divided by T1 is equals to P2 divided by P1 whole to the power of gamma minus 1 divided by gamma. Okay, T2 is equals pressure becomes 8 times, that means 8 times of P divided by P, EP gets cancelled. Okay, adiabatically gamma value 3 by 2 is mentioning, 3 by 2 minus 1 divided by 3 by 2, this is 2 to the power of 3 into T1, 2 to the power of 3, 3 minus 2 by 2, 3 minus 2 is 1, 1 by 2, 1 by 2, 2 gets cancelled, so this is going to become the 1 by 2, this is going to become 3 by 2, so 2 gets cancelled, so this is 1 divided by 3, so 3 gets cancelled into T1, that is 2 T1, and temperature 1 is given as how much? 273 plus 27, 27 plus 273, that is 300, that is 2 times of 300, that is 600 Kelvin, minus 273, 327 degree Celsius. So 327 degree Celsius is going to become your correct answer. Go through it. Expected question in again based on the adiabatic process. Moving on to the next expected question, most important question now for this end of the part 1 for the thermodynamic process. Final question. 1 mole of ideal gas with gamma equal to 1.4 adiabatically compressed so that temperature rises from 27 to 35. Change in internal energy is equal. We know the formula du is equals to m into Cv into dt. M can be written as number of moles is equals to mass divided by molecular weight. So mass is equals to number of moles into molecular weight. Cv can be written as what? R divided by gamma minus 1. dt, change in temperature is what? 35 minus 27. Okay, finally he is asking the value. 1 mole of ideal gas, gamma value 1.4 is saying. Number of moles is equals to what? 1. Number of moles is equals to 1. You know m into r is equals to Ru, universal gas constant, value is 8.314. Gamma is 1.4 minus 1, that is 0.4 it is. 35 minus 27. 27, 3 here, 5 there, 8 it is going to be 8. Now this can be written as 4 divided by 10, 10 goes to the numerator. Okay, this is 4 1s are 4 2s are, 10 goes to the numerator, 20. That means 83.14 2s are. If you say only 83 also, it is going to become 2 4s are 8, 2 1s are 2, 2 3s are 6, 2 8s are 16, 166.28. Change in internal energy. Is saying that 1 mole of ideal gas is adiabatically compressed. Adiabatically compressed means work is negative. When work is negative, then internal energy is what? Positive. Internal energy increases. So this is going to be a positive internal energy. Positive 166 joules is going to become your correct answer. Work is compressed. So that means work is negative. If work is negative, then internal energy of the molecules are going to increase. So du is going to become positive. Okay. So remember that logic. So this is the analysis of PYQ of the thermodynamic process part 1. Okay. See you guys in the next part 2. Until then, keep learning with the SAIMEDHA.in app, and don't forget to subscribe the channel, press the bell icon to be notified for every update from SAIMEDHA Hyderabad YouTube channel. Thank you very much.